You know, one of the things that I find most challenging about teaching Algebra 2 is that some of this is review, and some of you guys have learned these concepts but in different ways. And I don't like the idea of confusing you, but at the same time, I want to teach you what I feel like is the easiest way. Okay, so let me make sure that you understand what perfect squares are in general. Okay, I would love for you to be able to recognize these. I really would. And for most of you, you kind of get up into the 25, 36, 49, you're fine. But when you start getting into 121, 144, 169, like that's going to be a little bit harder for you. So when we talk about simplifying square roots, that's something that you're going to use later. Okay, we use it in Algebra 2 again, but you see it in pre-cal, you see it in any other math. Okay, I'm going to teach you a method that kind of works every time. All right, so it's nice if you can recognize square roots, but it's not always going to be required. Okay, so what we're going to do is simplifying square roots. That's what this is going to be called. Simplifying square roots. Okay. And the idea is that we always want to see prime factors. Okay, so we're going to break down numbers into prime factors. Okay. And prime factors are just numbers that can be divided by themselves in 1. Okay, so 2 is prime. It can only be divided by itself in 1. 3 is prime. 5 is prime. 7 is prime. 9 is not prime because 9 is divisible by 3. Okay, so that's what I mean by prime. So let's do an example. Okay, this is going to be the easiest way to learn these. So I'm going to do 3 or 4 examples here and talk about how we break down square roots. Now, 24 is not a perfect square. So what I'm trying to do is referred to as simplifying this square root. Now, some people would tell you to find the biggest perfect square. What I'm trying to do is to tell you that I want you to just break this down into prime numbers. Okay? So I want to just figure out any 2 numbers, okay, besides 1, we're not worried about 1, any 2 numbers that will multiply to give me 24. So not 1 and 24, but anything else. So I'm going to go with 2 and 12. Okay, 2 and 12. And then we're always going to stop, okay, when a number is prime. So we're basically going to make a little prime factor tree. Okay, so the only things that are going to multiply to give me 2 are 1 and 2. So this is what we call a prime number. I'm going to box that off. Okay, 12 is not prime. Okay, what times what will give me 12? Well, I have options, and it doesn't matter which one you pick. Okay, let's say 3 and 4. Okay, 3 and 4. So 3 is prime, so I'm going to stop right there at 3. Okay, and then 4, what times what will give me 4? That's going to be 2 and 2. All right, so you always want to figure out your prime number. So 2 times 3 is 6. 6 times 2 is 12, and 12 times 2 is 24. So these 4 numbers all multiplied together give me 24. That's why we call them the prime factors. So now what I do is I list them, and I always try to put the same numbers together. Okay. Now this has always been my trick. If it's a double, okay, if you are on a date, that means you get to go out. Okay, so I always circle my doubles, and then I underline my singles. My singles stay in, and my doubles go out. Okay, so right now I have a double 2, so that's going to go outside the square root. And then I have a single 2 and a single 3. So those have to stay inside. So the double goes outside, the singles stay inside, and then you basically just simplify whatever you have. So in this case you have 2, and then 2 times 3 gives me 6. Okay. So this guy, simplified, is 2 square roots of 6. These are equivalent to each other. Okay, and that's the idea behind it. Now, if I were to pick different numbers, okay, if I were to pick 4 and 6 here, you would end up with the exact same thing. So the purpose of prime factors is it doesn't have to be the exact same thing as me or as your partner or as, the person next to you. Okay, it could be, you can go whatever order you want and you're still going to get the same thing. Okay, so let's do another one. What about the square root of 32? Okay. Now the idea is The idea is, okay, I can break this down into any two numbers multiplied to give me 32. If I can recognize that this is 2 times 16, and I can say, oh, 16 is a perfect square. Okay, I know this 16 is a perfect square. That's the same as 4 times 4. Okay, what we can do is we can say, okay, well, that's the same as the square root of 16 times the square root of 2. If you recognize that, well, what is the square root of 16? Just 4. Okay, and you're done if you can recognize that. But if you can't recognize that, if that is difficult for you, then just create your prime factors. Okay, 2 is a prime factor. Okay, what times what would give me 16? Well, I'm going to say 2 times 8. 2 is a prime factor. I'm going to break down 8. I'm going to say 2 times 4. Again, boxing off every time I get to a prime number. Okay, 4 would be 2 times 2. I got a lot of 2's on this one, and that's okay. All right, looks like I've got 1, 2, 3, 4, 5. So I'm going to say 2 times 2 times 2 times 2 times 2. Always circle my doubles, and the doubles get to go out. Okay, and the singles stay in. Okay, they only go on one date, so both of these guys are not going outside. This double is going here. Okay, that's outside. This double is going here. And then the single has to be inside the square root. That's how we get 4 square roots of 2. So you get the same thing, okay, you just get it a little bit differently. All right? The reason that I'm looking at doubles is because this is a square root. I'm asking myself what times itself, okay, would give me this number. All right? So if it was a cubed root, okay, and I was dealing with a 3, I wouldn't be doing this same process. But square roots enable me to look for groups of 2, okay, because it's always what times what, okay, will give me that number. All right? It's kind of the intro concept here. I'm going to do 2 more very quickly, so I want you to see what these can look like. Okay, so this is example 3. If I have the square root of 5 times the square root of 18, okay, again, going back to the product property, I can multiply these together, okay, and I can say, well, that's the same as the square root of 90. Okay, it's the exact same thing. And then I can break this down, okay, and I can break this down into my prime factors. That's 9 times 10. Again, I know 9 is a perfect square, but if you don't recognize that, I'm just going to stick with my prime factor tree. This is 3 times 3. 3 is prime, nothing else. 2 and 5, both of those are prime. Okay, so I'm going to list off my prime factors, always putting my doubles together so I can see them clearly. There's a double, single, single, double goes outside, singles go inside, and then you clean up. Okay, so I do want to go ahead and multiply 2 times 5, so I get 3 square roots of 10 is my simplified version of that. Okay, look at one more. This is a division problem, so quotient property issue. If I have the square root of 9 over 64, okay, what I can do is I can look at that and I can say, well, so that's the same as the square root of 9 over the square root of 64. I don't even need to clean this up. Okay, these are perfect squares. Please recognize your perfect squares. The square root of 9 is just 3. I do not have to break that down into doubles. Okay, the square root of 64 is just 8. I do not have to break that down at all. Okay, so this would just be 3/8. That is basically your process of simplifying square roots. Okay, we have a couple of other situations that we need to talk about, but that kind of gives you the idea of what we're getting into.